All right. Let's look at the absolute value problems that we're going to see on test 2. You will see an absolute value equation. You will also see, expect to see one of each absolute value inequalities. So, in an absolute value equation, we take what we see in the absolute value bars. Once the absolute value is isolated, which it is on number 18, set it equal to the positive version of the right side, and set it equal to the negative version. On your note card, you could put something like the absolute value of x equals a becomes x equals a and x equals negative a, and then just work it out. Here we add 7 to both sides, so that 4x equals 12. Divide both sides by 4, and we get 3. Here we add 7 to both sides to get 4x equals 2, and we divide both sides by 4. We should reduce this. 2 over 4 is 1/2, and that's how we get our 2 answers. So on 20, we do not have the absolute value isolated. So our first step is to add 4 to both sides, so that the absolute value of 7x minus 5 equals 30. And so now the absolute value is isolated. It's an equation. So we remove the absolute value bars, set it equal to the positive version of the right, and the negative version of the right side. And just solve this out. Add 5 to both sides, so that's 7x equals 35, and divide by 7. So we get x equals 5. Over here, we'll get a fraction as we add 5 to both sides to get 7x equals negative 25. And then we just divide out the 7. So negative 25 over 7, which doesn't reduce, and x equals 5. In ALEKS, you were asked to put this together in a solution set. You could just kind of box your 2 answers. And then we get into the inequalities, absolute value inequalities. And we work these out differently. If it's a less than, I've been calling that case 1. And so if that's the case, then we take what's in the absolute value bars, x minus 7. We set it less than or equal to positive 10. But then on the other side, we copy that sign and we set it equal to the negative version of what we see. So again, we've talked about how to put that on a note card, but here we have our absolute value. Get rid of the bars. Copy what we see on the right. This is the positive version. Copy the sign and set it equal to the negative version of what it's less than or equal to. And then we just get x by itself. So here we have negative 3 is less than or equal to x is less than or equal to 17. Here we have an absolute value is greater than. And so it's the symbol that will determine if it's case 1 or case 2. If it's a greater than, then this is where we get the two kind of separate inequalities. So drop the absolute value bars, and it's greater than 12. We kind of just copy what we see. And then, this will give us the positive side of our number line. But what about the negative side? We take our x plus 10, we flip the sign, and instead of the positive version, it's the negative version. So if it's greater than, that's case 2. I'll make another video going over absolute value inequalities and kind of talking in depth about case 1 and case 2. But here we have our two separate inequalities in a greater than absolute value inequality. And the actual work isn't difficult at all. It's just knowing how to set up the problem. We get that x is less than negative 22. Over here, I subtract the 10 to get x is greater than 2. And so we have to think about how to put together our answer. I like to kind of visualize it on a number line that goes from negative to positive infinity. The points that we're concerned with are negative 22 and 2. So let's think about this. X is everything less than negative 22. To put that together on a number line, we would have an ending parenthesis at negative 22, and we would shade this direction. Over here, x is everything greater than 2. So we're pointing in the direction of a positive infinity, so we shade that direction. We get a parenthesis at 2, and for x is everything greater than 2, it's an opening parenthesis at 2, and then shaded to infinity. So what does that look like put together for full credit? Negative infinity to negative 22, unioned with 2 to infinity. This is the interval notation. How far does it go from the left to the right? Well, it goes from negative infinity to negative 22, and then we stop, unioned with, that's when we have two separate pieces on the number line, and then it picks back up at 2 to infinity. So you can try the other problems from the review, but we'll move on from there.